Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 2, which is the polynomials of NCERT textbook, and we'll try to cover the exercise 2.3, and this is our session number 3 for this particular chapter. Myself Deepak Gautam, TJT Mathematics in Kendriya Vidyalaya Sangathan. So let's start today's session. The chapter we are studying here is chapter number 2, polynomials, and this chapter is divided into 6 subtopics which are listed here. Out of this, we have covered the first 2 subtopics in the session number 1 and third subtopic in the session number 2. In this particular video, we're going to study the remainder theorem. So let's start. So the topic that we have, remainder theorem. I hope you know in which mathematical operation we come across the remainder, right? That operation is division. So you have been studying division since your class 6 or even before class 6. So let's recall that what you have studied. Suppose if we are to divide a number, let's say 25, by a number, let's say 4. If you divide the 25 by 4, we'll get, this goes 6 times, and 6 into 4 is 24. After subtracting, we'll get a remainder plus 1. So these values are called, this 4 is called divisor, this 25 is called dividend, this 6 is called quotient, and this 1 is called remainder. Okay, so there is a relation between in this all 4 values, that is the dividend is equals to the multiplication of divisor and quotient plus remainder. Okay, so this is the division of when we divide the simple numbers. In this exercise, we'll study about the division of the polynomials. Suppose if we are to divide a polynomial px by another polynomial gx, we'll get a quotient, let's say qx, and we'll get some number here. After subtraction, we'll get a remainder, let's say rx here. Okay, again this formula will be same for the polynomial also, that is this px, which is the dividend, will be equals to the multiplication of gx, which is the divisor, and multiply to the quotient qx, and plus remainder rx. And there is a condition for rx, that is remainder, that this remainder rx has to be less than or more than or equals to 0 and less than the number gx, that is divisor. This is the condition for remainder. The remainder has to be more than or equal to 0 and it should be less than gx. Based on this, we have few examples. So let's see the example number 6. The question says divide px by gx, where px is equals to x plus 3x square minus 1 and gx is equals to 1 plus x. So write a solution. We have px equals to x plus 3x square minus 1 and gx is equals to 1 plus x. So whenever we are given such polynomial, our first step is to write the polynomials in the decreasing order of the power of variable. So first we'll write 3x square plus x and minus 1 in the decreasing order of the power of variable. Similarly, with this one will be x plus 1. So these are our px and gx, and we are asked to divide the px, which is 3x square plus x and minus 1, by the another polynomial, which is x plus 1. Okay, so let's start this division. So in order to divide this number, we first look at the number of terms we have in the divisor. In divisor we have 2 terms, which is x and plus 1. So from dividend also we'll take the first 2 terms, which is 3x square and plus x. So in order to divide that, we firstly concentrate on the first number in both the polynomials, which is 3x square here and x here. So now we have to check what number should be multiplied to this x so that it will be equals to 3x square. So that number is 3x. So this 3x into x will result into 3x square, and this 3x into plus 1 will result into plus 3x. Okay, now subtract them by reversing the sign. This plus will reverse to minus, and this plus will also reverse to minus. This 3x square and minus plus 3x square and minus 3x square will be cancelled out, and will remain with x minus 3x plus x minus 3x will result into minus 2x, and then we'll take down the next value, which is the minus 1, because we will operate only with the two numbers. So now again concentrating the first number here and first number here. Here we have xn and here we have minus 2x. So what should be multiplied to this x so that it will be equals to minus 2x? That is, we need to multiply here minus 2. Minus 2 into x will result into minus 2x, and minus 2 into plus 1 will result into minus 2. Okay, now again subtract them by reversing the sign. This minus will be changed to plus, and this minus again will reverse to plus. So this minus 2x and plus 2x will result into 0, and this minus 1 and plus 2 will be plus 1. So now we have this remainder 1. So we'll write remainder is equals to plus 1. Okay, we are asked to divide the px by gx. After division we got the quotient as 3x minus 2 and the remainder plus 1. Okay, that's how we divide a polynomial by another linear polynomial. Moving ahead to the next example, we have example number 7. Here you are asked to divide the polynomial 3x power 4 minus 4x cube minus 3x minus 1 by the another polynomial x minus 1. So write its solution. We have px equals to 3x power 4 minus 4x cube minus 3x minus 1, and gx is equals to x minus 1. Now you can see the number are already arranged in the decreasing order of the power of variable. Okay, here we have 4 power x power 4, x power 3, x power 1 and x power 0, and similarly here in gx. So now write them in the division form. That is px, which is 3x power 4 minus 4x cube minus 3x and minus 1, and it will be divided by x minus 1. Okay, now we again have two terms in the divisor, so we'll take the first two terms of the dividend and we'll concentrate only on the first terms here. Again we have to look for a number which when multiplied to x will result into 3x power 4. So that number is 3x cube. 3x cube into x will result into 3x power 4, and 3x cube into minus 1 will result into minus 3x cube. Okay, now we'll subtract the number by reversing the sign. So this plus will be changed to minus, and the minus will change to plus. So this is plus x power 4 and minus x power plus 3x power 4 and minus 3x power 4 will be cancelled out, so we'll remain with minus 4x cube and plus 3x cube. So minus 4 and plus 3 will result into minus x cube, and we'll take down the next number now, which is 3x. Okay, now again we'll look at this first number here and here. So what should be multiplied to this x to make it equals to minus 3x cube? So that number is minus x square. Minus x square into x will result into minus x cube, and minus x square into minus 1 will result into plus x square. So now we'll subtract them by reversing the sign. This minus will reverse to plus, and this plus will be reversed to minus. Again minus x cube and plus x cube will be cancelled out, so we'll remain with minus 3x and minus x square. Now you can see both these numbers have a different power of variable, so we cannot add or subtract them, so we'll write them as it is, which is minus x square and minus 3x. Since we already have two terms here, so we'll not take down the next term. we operate with this term first. So we'll concentrate, or we look at this first number, which is minus 3x square. Sorry, minus x square and minus 3x. So this first term here is x is minus x square. Here we have x. So we need to multiply now. We need to multiply minus x. Minus x into x will result into minus x square, and minus x into minus 1 will result into plus x. Again reverse the sign, minus will change to plus and plus will change to minus. So this minus x square and plus x square will result into 0, and this minus 3x and minus x will result into minus 4x. Okay, now next number is, what should be multiplied to this number? So first we'll take down the last remaining number, which is minus 1. So again we'll look at the first number here. So now we have to multiply minus 4 to make it equals to minus 4x. So minus 4 into x will result into minus 4x, and minus 4 into minus 4 into minus 1 will result into plus 4. Okay, again reverse the sign. This will change to plus and this will be reversed to minus. So these two will be again cancelled out. We remain with minus 1 and minus 4, that will result into minus 5, and that's our remainder. Okay, that's how we divide the polynomial by another polynomial. Now see next question. Next example is px is equals to px equals to x cube plus 1 and qx is equals to x plus 1. Its solution will be, again find the remainder obtained by dividing the number polynomials. While px is x cube plus 1 and gx is x plus 1. So we'll write them in division form, which is x cube plus 1 divided by x plus 1. So now we again, as there are two terms, so we'll take both the terms from dividend also. So what should we multiply to this x to make it equals to x cube? That number is x square. So x square into x will result into x cube, and x square into plus 1 will again result into x square. Okay, now subtract them by reversing the sign. Plus will change to minus. These two will be cancelled out, so we'll remain with minus x square and plus 1. As we don't have any variable term here, so we'll write them as it is. Okay, now again taking the first term here, we have minus x square and here we have x. That means we need to multiply it by minus x. Minus x into x will again result into minus x square, and minus x into plus 1 will result into minus x. So now these two will be cancelled out after reversing the sign, and we remain with x plus x and plus 1. So what should be multiplied now? Now you can see that x plus 1 we have is equals to the x plus 1 here. That means we need to multiply now 1. 1 into x is x and 1 into 1 is 1. Okay, so now subtract them by reversing the sign. You will get 0 here and here, so remainder here is 0. Okay, so remainder is 0. So we have done the example of the division of a polynomial by another polynomial, and we got the remainder in all three cases. Okay, now before coming to the next example, let's have a look at what the remainder theorem is. The remainder theorem says, let px be any polynomial, like we had in the three examples. Px is any polynomial of degree greater than or equals to 1, and like we said in the examples, the polynomial had the degree greater than or equal to 1. Let a be any real number, and a is any real number, if px is divided by the linear polynomial x minus a, then the remainder is pa. Okay, it says if you have a linear polynomial x minus a, the value from here, which is a, if you put this value a here in the polynomial px, this will result into, by solving it you will get the remainder directly without doing the division. Okay, that is, if we put this value of a from this x minus a into the given polynomial px, after solving that we can directly find out the remainder without doing the division. Okay, let's see this in the example that we have already solved. We have this example number 8. In this example, first see this example number 6. Okay, the gx that we had here is x plus 1. The gx, if we put this equals to 0, so gx is x plus 1 equal to 0, the value of x here is will be minus 1. Okay, if we, so that means this is the value of a. If we put this value of a in the given polynomial, which is px, equals to 3x square plus x minus 1. That means now if we replace all the x's by minus 1, so we'll get 3 into minus 1 square plus minus 1 and minus 1 here. So this will be minus 1 square is plus 1, and plus 1 into 3 is 3, and this plus 1 and minus 1 will result into minus 1, and then we have again minus 1. So this will result into plus 1, which is equals to the remainder here that we have got after the doing the division. That means by using directly applying the remainder theorem, we can find out the remainder of any polynomial. Okay, based on this we have a question, example number 9. You will understand this better now. It says find the remainder when this polynomial is divided by x minus a. So we'll not do the division, we'll directly use the remainder theorem. So its solution will be, we have px equals to x power 4 plus x power 3 minus 2x square plus x plus 1, and gx is equals to x minus 1. Okay, so what we're gonna do is, first we put let gx equals to 0, and the value of gx is x minus 1 and equal to 0. From here the value of x will be plus 1. Okay, now we'll write using remainder theorem. You have to write this remainder theorem. We write p this polynomial and we'll replace the value all the x's by 1. So that is p of 1 will be, will replace all the x by the plus 1. So at the place of x we'll write plus 1 minus 2x square, that means 1 square plus x, that is 1 plus 1. So this 1 power 4 will be 1, 1 cube will be again 1, this 1 square will be 1 into 2 is minus 2, and then we have plus 1 and plus 1. So this will be 1 plus 2 plus 1 2 3 4, that is plus 4 minus 2. So answer is minus 2. So the remainder, not minus 2, is plus 2. So the remainder here is plus 2. So we can directly find out the remainder without doing the actually long division, okay, by using the remainder theorem. Okay, you will understand this better when we do some more example and the question of the exercises. Okay, now see the next example, which is example number 10. It says check whether the polynomial qt equals to 4t cube plus 4t square minus t and minus 1, and it is multiplied by, let's say it's gt, which is 2t plus 1, and we are asked to check whether this is a factor of this number. So in order to check if this t 2t plus 1 is a factor of the given polynomial, we'll find out that by putting the value of t from this gt. If this result into 0, that means this polynomial is a factor of the given polynomial. Okay, that means let gt is equal to 0. Okay, the value of gt is 2t plus 1 equal to 0. So from here 2t will be equals to minus 1, or t will be equals to minus 1 by 2. So now we'll use this value of t in the given polynomial. If it result into 0, that means this t plus 1 is a factor of the given polynomial. Okay, so let's check the polynomial that we have. We'll write using remainder theorem. This polynomial is q of 1 minus 1 by 2 is equals to, we'll replace all the t's by the minus 1 by 2, that is 4. Then we have minus 1 by 2 power 3 plus 4 minus 1 by 2 square minus 1 by 2 and minus 1. So this is, we have 4 minus 1 by 3 cube will be minus 1 by 8, plus we have 4, this minus 1 by 2 square will be plus 1 by 4, then we have minus will become plus 1 by 2, and we have minus 1. So this will result into minus 1 by 2. These two will be cancelled out, and we get plus 1 by 2 and minus 1. So these two will be cancelled out, and this plus 1 and minus 1 will be cancelled out, and the result is 0. That means this gt, which is 2t plus 1, is a factor of the given polynomial. That means, so 2t plus 1 is a factor of the given polynomial qt equals to 3t cube plus 4t square, 4t cube plus 4t square plus minus t and minus 1. So that's our answer. This factor means multiple. Okay, you can write its place multiple also. So 2t plus 1 is a factor, or you can say multiple of the given polynomial qt equals to 4t cube plus 4t square minus t and minus 1. Okay, so this is the solution of the example number 4. Now moving ahead to the exercise 2.3. The exercise says find the remainder when polynomial x cube plus 3x square plus 3x plus 1 is divided by the following polynomial. So let's start with the first part. Answer number 1, part 1. The polynomial that we have here is px equals to x cube plus 3x square plus 3x plus 1. Okay, write part 1 here. We have gx equals to x plus 1. Okay, so write let gx equal to 0. That means at the place of gx we'll write x plus 1 equals to 0. or x from here will be minus 1. So write by remainder theorem or using remainder theorem, now we write this value of x in the given polynomial. P of minus 1 is equals to, at the place of x we'll write the minus 1, that is minus 1 cube plus 3 minus 1 square plus 3 into minus 1 plus 1. So minus 1 cube will result into minus 1. This minus 1 square is plus 1 into 3, plus 3 will be plus 3 again. This plus 3 into minus 1 will result into minus 3, and we have plus 1. After solving it, you will get the answer as 0. Okay, moving ahead to the part second. The second part is now gx is equals to x minus 1 by 2. So write let gx equal to 0. Gx is x minus 1 by 2 equal to 0, or x will be equals to 1 by 2. Okay, again write using remainder theorem, p of 1 by 2. Okay, in this polynomial again we write, replace all the x by now 1 by 2, so that is 1 by 2 cube plus 3 1 by 2 square plus 3 1 by 2 plus 1. This 1 by 2 cube will be 1 by 8 plus this 1 by 2 square will be 1 by 4, that is it will be 3 by 4 plus this will be 3 by 2 and plus 1. Now we have to solve this by taking the LCM of all the number. So the LCM of this 8, 4, 2 and assuming 1 here will be 8. So we'll write the common denominator 8. So we already have 8 here. In order to make 8 here, we need to multiply 2 here. So we'll multiply 2 here also. So it will be plus 6. And we have to multiply 4 here and 4 here. So it will be 3 into 4 is 12. And then 8 here and 8 here. So this will be 8 equals to this 12 plus 8 is 20. 20 plus 6 is 26. And 1 is 27 by 8. That's our answer of the remainder. So when you divide these polynomials, you will get the remainder 27 by 8. Moving ahead to the next part, which is now x. Now gx is equals to x. So let gx equal to 0. That means x is equals to 0. That means using remainder theorem, will replace all the x's now by 0. That is p of 0 will be equals to 0 cube plus 3 0 square plus 3 into 0 plus 1. So 0 cube will be 0. Again 0 square multiplied to 3 is 0, and this 3 into 0 is 0 plus 1. So result is plus 1. So the remainder now is plus 1. Okay. In the end of each you have to write in the next line, hence the remainder is 0. Okay, you have to write this in the next line. Similarly you will write hence the remainder is 27 by 8. Okay, here also write hence the remainder is plus 1. Okay, moving ahead to the next part. Let me extend the writing area. Okay, next part here we have now x is equals gx is equals to x plus pi. That means let gx is equals to x plus pi, not x plus pi. First we'll write let x equals to 0. That is x plus pi is equals to 0, or x will be equals to minus pi. That means we'll have to replace all the x's by minus pi. So using remainder theorem, p of pi will be equals to pi cube plus 3 pi square plus 3 into pi plus 1. So this will be pi cube plus 3 pi square plus 3 pi plus 1. So that will be our answer. The remainder will be pi cube plus 3 pi square plus 3 pi plus 1. Let's see the last part of this question. Part 5, we have gx equals to 5 plus 2x. So write let gx equal to 0. That is 5 plus 2x equal to 0. That means 2x is equals to minus 5, or x will be equals to minus 5 by 2. Okay, now we have to replace all the x's by minus 5 by 2. We have, using remainder theorem, p of minus 5 by 2 is equals to minus 5 by 2 cube plus 3 multiplied by minus 5 by 2 square plus 3 into minus 5 by 2 plus 1. So this will be, okay, I'm leaving it here. You have to solve it by yourself by finding the first cube, square, and then multiply it by their coefficient and solve this by taking the LCM. Okay, I'm leaving it for you. You will solve it by yourself now. Moving ahead to the next question, we have find the remainder when x cube minus x square plus 6x minus a is divided by x minus a. So it's again very simple, like we have been doing in the first question, that is answer number 2. We have let px equals to x cube minus ax square plus 6x minus a, and gx is equals to x minus a. So all right, let gx is equals to 0. That means x minus a equal to 0, or x will be equals to a. So again writing by using remainder theorem, using remainder theorem, the p of a, that is at the place of x will write a. So a cube in minus a into a cube plus 6 a minus a. So it will be a cube minus a cube plus 6a minus a. So plus a cube minus a cube will be cancelled out, and this 6a minus a will result into 5a. So the remainder here is 5a. So right, hence the remainder is 5a. Okay, let's come to the last question of this exercise. We have check whether 7 plus 3x is a factor of 3x cube plus 7x. So write answer number 3. Let px equals to 3x cube plus 7x, and gx is equals to 3x plus 7. I have arranged them already, okay, in the decreasing order of the power of variable. So let's say let gx is equals to 3x, so 3x, let gx is equal to 0, that is 3x plus 7 equals to 0. Okay, so from here x will be 3x equals to minus 7 and x will be minus 7 by 3. Now we have to put this value of x in the given polynomial. If the result is 0, that means this will be a factor of the given polynomial, otherwise not. So using remainder theorem, p of minus 7 by 3 is equals to, we have 3, at the place of x will write minus 7 by 3 cube plus 7x, again minus 7 by 3. Okay, so this will be 3 into minus 3 cube is 343, sorry, 7 cube is 343 and 3 cube is 27. This plus and minus will become minus. 7 into 7 will be 49 by 3. Okay, this 3 will result into give 9 here, so this will be minus 343 by 9 and minus 49 by 3. So LCM of 3 and 9 will be 9, so this will be 343 minus, we need to multiply 3 here and 3 here, so this will be 147. So now to subtract them to find the final answer, that is after subtracting 343 minus this number, so after subtracting we will get 691 by 9, and which is not equal to 0. That means the given number is not a factor of the given polynomial, so this number is alright. Therefore seven plus 3x is not a factor of 3x cube plus 7x. Okay, that's the solution for this question. Now we have done all the questions of the exercise 2.3 and all the example given before this exercise. So now your task is to practice all the questions multiple times so that you will understand them better and you'll be fluent in solving them. Okay, if you have any doubt or difficulty, you can ask me that in the comment box of this video, or you can send me a message on WhatsApp personally. Okay, so that's all for today's session. Thanks for joining here. Thank you.